Moto 371 final project, we had to look at a GM transmission and discuss its various components. The GM transmission we were assigned is a 4T60E. 4 stands for 4 speeds forward, T is transversely mounted, 60 is a torque capacity, and E stands for electronically controlled. This is one of the first transmissions that has been electronically controlled. It is front-wheel drive, and it was produced from 91 to 99. The vehicle that we took this out of is an Oldsmobile 88 from the year 1999. It is a transmission with a double-axis design, meaning that the power comes in through the torque converter from the output of the engine and is chain driven through a gear set and a chain, and then power is transferred through the clutches, bands, and all the other components that we'll discuss later via that chain. The service intervals are about 30,000 miles. So every 30,000 miles it's suggested to service this transmission. And it utilizes a 7-position manual valve. The 7-position manual valve includes manual low, which would be your first gear, second gear, which is also a manually selected gear. Then you have your drive position, your overdrive position, your park, your new. In the 7-position manual valve, there's also a reverse gear selection. For this project, each of the members in my group were assigned a particular portion of the transmission to study and present on. Hydraulic is one, mechanical is another, and electrical is another. First, we'll start with the mechanical components.
My name is Christian Pena, and I was assigned to do the mechanical portion of this transmission. As my colleague said earlier, this transmission is chain driven, so therefore we have a chain here that's driven by the drive sprocket that's splined to the turbine shaft, which is splined to the torque converter. This is our 4th clutch hub and shaft assembly. Our chain drives this right here, which is our driven sprocket. This is splined to our input housing and clutch assemblies. Sorry guys, bear with me. This here is our driven support sprocket. It also houses the 4th clutch piston and return assembly. And another unique thing about this is it has ports for hydraulic fluid delivery for every clutch pack. So weird. Here we have our 2nd clutch, which also we have our reverse band. And the reverse band is only applied in reverse. And it pulls the 2nd clutch in reverse. Sorry guys. Here we have our reverse reaction drum, which is also used in reverse only. This is actually splined to our 2nd clutch and our front planetary carrier. This here is our input clutch assembly / housing. It houses our input clutches and our 3rd clutches. Here we have our Sprag clutches, which is splined to this portion is splined to the input clutch, and the rear portion is splined to the 3rd clutch. And the way these Sprag clutches work is, in one way they hold, as you can see I cannot spin this, and another way they overrun. Here we have our input sun gear, which is splined to our front planetary carrier / pinion gears. Here we have our front planetary carrier and rear ring gear, which also our reverse reaction drum splines into these little tabs. Here we have our rear planetary carrier with our front ring gear. This is our reaction sun gear. This is practically held at all times, and it is splined into our our rear planetary carrier, and our manual 2-1 band goes over our reaction sun gear. And here we have our 1-2 support roller clutches, which also has our forward band around. And now going to the end of the transmission. This is our final drive sun gear shaft. This is our final drive reaction member. It's the ring gear for the differential also. This is splined to the case, and it also has our parking bevel. And last but not least, we have our differential. And this is our final drive sun gear, which splines into the differential. And, oh, putting that the wrong way. And also, our final drive sun gear shaft, our final drive shaft splines into this final drive sun gear, which powers the output shaft. Now that I have ID'd all the major components of the 4T60E transaxle, I will now demonstrate how power flows through the 4T60E GM transaxle. And this transaxle is capable of achieving 4 different gears, along with reverse also. And when the vehicle is first turned on, the input clutch is applied right away because you're either going into first gear or reverse gear, and this drives in both gears. So we'll start off with reverse first. For the bigger picture, our second clutch housing, which also has the reverse band around it, is splined into the input clutch housing assembly. And when reverse is applied, the reverse band holds the second clutch housing assembly, which holds the reverse reaction drum, which in total holds the front planetary carrier. And when this is all being held, this allows the gear sets to operate in reverse. For example, the reverse reaction drum holds the front planetary carrier, and this way you achieve reverse. As you can see, the differential carrier is operating in reverse direction, and we achieve a 2.38 to 1 ratio. For first gear, it's identical to reverse, except that instead of the reverse band being applied, the forward band is being applied, which wraps around the 1-2 support roller clutch, which is this component down here. And to achieve first gear, you hold the reverse, or the forward band is being applied, and this is how you achieve first gear. And the first gear ratio is a 2.92 to 1. To achieve second gear, the second clutch is applied. As I stated earlier, the multi-disc clutch pack and steels are splined to the input shaft housing assembly, which causes this to rotate with the input shaft, which rotates the front planetary carrier, and this is how you would achieve second gear, which provides you with a 1.56 to 1 gear ratio. For third gear, the second clutch and the third clutch are applied. This way, I'm going to need one of my colleagues as an assistance. So when the third clutch is applied, it holds the third sprag clutch because the inner race of the sprag clutches, or the inner race which is splined to the input sun gear, wants to rotate faster than the outer race of the third sprag clutch, which this causes the third sprag clutch to mechanically lock up with the input sun gear, providing you a direct gear ratio of a 1 to 1. So can you please hold this top, sir? And this is how you would achieve third gear. Oh. Yeah. Which, like I said earlier, that is a 1 to 1 ratio. Now for fourth gear, our fourth clutches are sitting behind this fourth clutch shaft assembly. And when the fourth clutches are applied, they hold the input sun gear, which then, and the second clutch is applied, which drives the front planetary carrier. So, Greg, please, can you hold this top for me? So when the input sun gear is being held, and the forward band is being held, and the front planetary carrier is being driven, this allows, this right here is fourth gear, which gives you a ratio of a 0.701.
For the hydraulic part of this transmission, there's multiple components involved. I'll talk about each one of them individually. Our channel plate is the bottom half of our valve body assembly. It will mate with the valve body assembly, which is here. Included in the channel plate, you have your manual valve, which is located right here. It comes all the way through to the other side and directs fluid according to which valve, which gear the driver is selecting. Next, we have the main part of your hydraulic assembly. This is your valve body assembly. Inside the valve body assembly, we have multiple valves included that direct fluid in various different ways. It's falling apart. So, on this side of our valve body, we have our solenoid B, which will plug into here, into this port. This is our 3-4 valve. Our 2-3 valve is here. And there is a secondary and a primary accumulator valve assembly here. So this is your 1-2 and 3-4 accumulator for your secondary, and your 1-2 and your 2-3 accumulator for your primary. On the other side, there's a bunch of different valves as well. This is your converter clutch lockup valve right here. So when the converter clutch needs to go into lockup, this valve will actuate. This is a pulse width modulated solenoid, which will be discussed more in depth about in the electrical portion. This is your converter clutch regulator valve, which regulates the pressure going to the torque converter. This is a pump pressure regulator valve, which is simply just a check ball that unseats when pump pressure exceeds a certain value. Solenoid A will come into this opening right here. This controls your 1-2 shift valve. And then finally, you have your line pressure regulator valve right here, which boosts your line pressure in reverse or at any other time when increased line pressure is needed. Just for a quick visual, this is what a valve will look like on the inside. The manual valve also looks similar, it's just much bigger. So the pump will mate up to this face of the valve body, the lower valve body control unit. In this transmission, you have a pretty interesting type of pump. This is just what the pump looks like. The pump is called a variable vane displacement pump. There's a filter, let me just hold that. There's a filter for your suction on this side. So, as fluid gets sucked in, the pump will turn itself and build pressure. This part moves, which makes it variable. There's usually a spring in here that will hold it closed, but hydraulic pressure will push it this way, which will increase line pressure, and this way, which will decrease line pressure, according to the different loads that are on the vehicle. There's several other hydraulic components of which I will talk about being here. These are all controlled hydraulically and do various different things within the transmission. So this is a servo, this is also a servo. So these are both different types of servos. There is one more servo in this transmission which we don't have for the video. This is your manual 2-1 servo assembly. Pressure will come from the bottom pump into these two inlet ports here. And the way a servo works, if I can get this to open, I can explain it using this one. The way a servo works is line pressure will come in underneath here and apply fluid pressure as this lip seal seats against the walls of the cylinder, which will then push this up or down or whichever direction it's going to go and apply the band in which it is associated with. So for this is your forward band. This will apply your forward band around your forward drum and hold it in place. This is actuated in all forward gears. This is your 2-1 manual, so this is associated with the 2-1 band, which goes around the 2-1 drum, which would then hold that when this was actuated. An accumulator is similar. It's a similar type of application to a servo, but it's not applying an element. It's used in line with the applied elements or clutch packs. Fluid pressure will enter into the accumulator and push a piston up, which will take time to displace the fluid within the accumulator. This will allow for a smoother apply of your clutches or your bands for whichever accumulator is being used. There are 3 accumulators within this transmission. This happens to be the 3-4 accumulator, which is located in the channel plate and is seated just like that. This is the only accumulator that's located within your valve body or channel plate assembly. The other accumulators are located within the sump of the transmission, so just basically in the bottom of the pan. Finally, one more hydraulic component that is the most interesting one to me is called a vacuum modulator assembly. So the reason why this is considered a hydraulic component is because it is used to control line pressure based on engine vacuum or atmospheric pressure. The most similar thing I can compare it to is a brake booster. There's a diaphragm on the inside. There's manifold vacuum applied to this right here. And when the vehicle is under load, the vacuum will apply here and pull this diaphragm in, which will then pull this in, and it will increase line pressure. When there is no load on the transmission, or no load on the engine, engine vacuum will decrease and allow atmospheric pressure to press on this side of the diaphragm, push this pintle forward, and therefore will decrease line pressure. So because the transaxle is driven hydraulically, mechanically, and electrically, all of the components are somewhat related. So I'll start by discussing that this has already been labeled. This is called the drive sprocket support. This is bolted directly to the valve body, and there's fluid passageways all throughout here that come from the pump through the valve body, through the drive sprocket support, and into the case of the transmission. These are lip seals right here. I can't get it to come off. These are your lip seals. Hydraulic fluid is transmitted through the whole powertrain through the case and or through cutaway fluid passages. There are holes in this input drive assembly where fluid will enter. There's 3 of them throughout this shaft. There's 3 lip seals here as well that seal against leakage inside the transmission. Fluid will enter through these holes and apply these clutches on the inside, holding different components on the inside as well. When venting, when hydraulic pressure is no longer needed on the inside of this to apply the clutches, fluid is vented through centrifugal force. As this is spinning, there's a vent on the back here. It's a small little port. And as this is spinning, hydraulic fluid will then vent out of here and go to wherever it is needed. There's another vent on this second clutch, which is right there. For reverse gear, you have 2 elements that are applied to achieve reverse. Your reverse servo, which applies your reverse band, and your input clutch, which is a multi-disc clutch pack, which is also applied. Both of them are applied using hydraulic pressure. Hydraulic pressure is generated obviously by the pump, and in this diagram it'll show you that the pump pressure comes from here through this filter and up through the pressure regulator. Through the pressure regulator there is another hydraulic line, which hydraulic pressure will come onto this side of the pressure regulator valve, shifting it this way, adjusting your line pressure to the correct pressure that is needed for the reverse gear. Line pressure will follow that path to the manual valve. There's 2 directions in which the fluid can go from here. It can go this way, which is towards your B solenoid, or it can go through the manual valve. We'll start with that. It will go through the manual valve and up through, while your manual valve's in the reverse position, because you're looking to achieve reverse gear. A hydraulic pressure will come through this valve here, the manual valve right here, and travel up to your reverse servo through this pathway here. There's a number 5 check ball in the reverse servo circuit that is seated during this, which will allow the fluid pressure to go through your reverse boost valve. After it goes through your reverse boost valve, it will then come onto the back side of the reverse servo, applying the piston and also applying your reverse band, which will hold your reverse drum. Going back to here, after line pressure goes through your regulator valve, like I said, it can also go through your manual valve, and it will also travel down this way to your your B solenoid. In reverse, both solenoids are on. Here's your B solenoid and here's your A solenoid. We'll talk about that one in a minute. Your hydraulic pressure will come into your B solenoid port, and it is not allowing fluid to be exhausted at this time because it is energized. So fluid will be diverted around the solenoid and onto this side of the 4-3 shift valve, and also onto this side of the 3-2 shift valve. So we'll push both of these valves in the direction opposite the fluid flow. So for solenoid A, you'll have line pressure that comes from your pump. Does not go through the pressure regulator valve, but instead comes directly down through to your solenoid. Because the solenoid, like the B solenoid, the A solenoid is also on and is not allowing fluid to be exhausted. So fluid will come and travel down this blue line will travel down to your 3/4 shift valve, and it will stop there. Line pressure also from your pump will travel down through your 2/3 shift valve, and again up through your 3/4 shift valve. This is your input clutch feed, which will eventually make its way up to your input clutch and apply that. So after it goes through the 2/3 shift and the 3/4 shift this way, the input clutch feed is coming up here and all the way to the back side of the apply piston for your multi-disc clutch pack on your input clutch assembly. For first gear, there's two elements that are applied: your forward servo and your input clutch. Both are applied hydraulically. The forward servo will apply your forward band. Hydraulic pressure comes in from your pump and is regulated by the pressure regulator valve. Regulated pressure is going to go through your manual valve in the drive position and enter the D4 circuit. The D4 circuit will allow fluid to go to your forward servo boost valve, which is here, your 1/2 shift valve, which is down here, your 2/3 shift valve, which is here, your 1/2 accumulator valve, and your 3/4 accumulator valve, which is here and here. Also 1/2 accumulators here. Your D4 circuit will flow hydraulic fluid through your number 6 check ball and a thermal element. Your thermal element is used to control hydraulic fluid based on temperature. Once it goes through this circuit, your servo apply fluid will travel all the way down to your forward servo. Hydraulic pressure will be applied to the reverse side of the servo piston, applying your forward band, which will hold your forward drum in first gear application. Line pressure will come in from here and also find its way to your B solenoid, which is on. Your A and B solenoid are both on in first gear, which do not allow fluid to exhaust. Hydraulic fluid will come down through this orifice here, be blocked by the B solenoid, and fluid will come to your backside of your 4/3 shift valve and your 3/2 shift valve, both pushing both of these valves in this direction. Line pressure will also enter into your A solenoid circuit. Like I said before, the A solenoid is on and will allow fluid in this way and push your 1/2 shift valve in this direction. A solenoid fluid pressure will also come down to your 3/4 shift valve here and terminate. The D4 circuit, as well as feeding your forward servo, like I said earlier, will feed your 2/3. It will also feed your 1/2 accumulator, and it will also feed your 3/4 accumulator. So the D4 circuit, which is located right here, fluid will come in through your 2/3 shift valve, which is being held in the position that it's in by your B solenoid pressure, it will go to your, it will flow through this valve into this portion of the circuit, and again up and through the 3/4 shift valve, which will turn into your input clutch feed, which is here, through your number 3 check ball, and the hydraulic fluid will find its way to the back of the input clutch, the back of the piston for the input clutch, applying your multi-disc clutch pack. Fluid pressure from in the D4 circuit also finds its way to the 2-3 accumulator and the 1-2 accumulator. For the 2-3 accumulator, your fluid pressure will come in through the valve and out up to your 2-3 accumulator. For your 1-2 accumulator, it will have to transfer from the 1-2 accumulator through the 1-2 accumulator valve up through the secondary 1-2 accumulator and then out all the way to your 1-2 accumulator. Your 3/4 accumulator comes from your D4 circuit feed, which will come through the 3/4 accumulator valve, be exhausted through this circuit, and fill your 3/4 accumulator. The only other portion of this hydraulic circuit that is important for first gear is your modulated line pressure, your modulated line pressure that comes from your vacuum modulator. So just direct line pressure from your pump will come through here, and according to your intake manifold vacuum, it will redirect your fluid to the backside of the 2-3 accumulator and the backside of the 3/4 accumulator, putting the valves in the proper position for first gear. For second gear, there's 3 elements that need to be applied. Your input clutch, which is the same element that's applied in first gear. Your forward servo, which holds your forward band, which is the same element that's applied in first gear. What makes first gear different from second gear is that you also have your second clutch applied. These 3 elements combined is what gives you second gear. You're still going to be in the drive position on the manual valve, and line pressure is still going to be regulated through the pressure regulating valve. Your servo, your front servo, your forward servo is applied in the same way that it is applied in first gear, through your D4 feed circuit, which will come up through your thermal element and your forward boost, and straight down to apply your forward servo and your forward band. The D4 line pressure will, as well as feeding the forward servo, will ultimately feed your second clutch and your input clutch. So following the diagram down, your D4 fluid pressure will come in through your 1-2 shift valve, which is moved in the position that it's in because the A solenoid is off and spring pressure is pushing the valve this way. So the D4 fluid pressure will come in through your 1-2 shift valve, flow through the valve, and over, and this now turns into your second clutch circuit. So your hydraulic pressure will come up in your second clutch circuit, and the 1-2 accumulator is used in the second clutch circuit. So your fluid pressure will come underneath this accumulator and push this piston upwards, which will dampen the apply of your second clutch. As you can see here, fluid pressure will come into the accumulator. As it's dampened, it will also flow out once this accumulator is filled. The fluid that's on the opposite side of the accumulator will be pressed out from the pressure on this side, and will vent through the secondary 1-2 accumulator. The vent rate will be controlled by your primary trim, which is line pressure that comes from your 1-2 accumulator, which ultimately comes from your D4 circuit. The 2-3 accumulator and the 3-4 accumulator are both at rest for second gear.
and the B solenoid is on. The B solenoid is doing the same thing that it would be doing in first gear. Line pressure will come in. Because the B solenoid is on, it will be redirected down to the 4-3 shift valve and the 3-2 shift valve, pushing them both in this direction. That's how second gear is achieved. Your forward servo, which is applied in every forward gear, just like first and second. Your second clutch is also going to continue being applied. The only difference between first and second is your input clutch will be being released and vented, and your third clutch will be applied in its place. So line pressure, you're still going to have the D4 circuit. The line pressure will come through the D4 circuit and apply your forward servo the same way it does in first and second gear. In third gear, your solenoids are both off. Your A solenoid and your B solenoid are off, resulting in the fact that third gear is your limp-in gear for this transmission. You can also access second gear with a manual 2-1 band in limp-in mode. Line pressure for third gear will follow the D4 circuit again and come down to your 2-3 and your 1-2 accumulator, which will flow through your 1-2 accumulator to your primary trim and go to your secondary 1-2 accumulator valve, holding it open, which will control your venting of your 1-2 accumulator under pressure. The venting of the 2-3 accumulator will be controlled by your 3-4 accumulator, by your 2-3 accumulator in this case, which will allow the fluid that's on this side of the piston to vent when it's under pressure from your third clutch apply fluid pressure. Your third clutch fluid pressure will be coming through your 1-2 shift valve this way, through your number 9 check ball, up into your 2-3 accumulator, which will dampen the apply of the third clutch. Like I said before, both the A and the B solenoid are off, so they are both exhausting fluid, or in simpler terms, they're allowing fluid to flow through them. It's best shown here. Your fluid that is being pushed out of the 3-2 downshift valve and out of your 4-3 downshift valve, the fluid will be pushed out this direction and come through and exhaust through your B solenoid. For the A solenoid, it's also being exhausted. Your 3-4 shift will push fluid, existing fluid out of the 3-4 valve this way, and will find its way past the A solenoid to exhaust that pressure as well. Your second clutch is applied in the same way as it would be applied in second gear. The second clutch fluid will come from your D4 circuit through the 1-2 shift valve and find its way up through the number 2 check ball, which will then follow all the way to the second clutch and apply your second clutch. Second clutch fluid will also find its way down to the converter clutch solenoid, which is off and allowing fluid to vent through it as well because it's exhausting. There's no lockup in third gear. So like I said earlier, your second clutch is applied, your forward servo is applied, and your third clutch is applied while your input clutch is being released. Your input clutch fluid pressure is going to be released through centrifugal force. There's a check ball in this housing which will unseat and allow your input clutch pressure to then vent while your third is being applied. So your vented input clutch hydraulic fluid will be vented through your 3-4 shift valve utilizing the D3 circuit. In this case, your 3-4 accumulator is at rest. And that's how third gear is obtained in the 4T60E. In fourth gear, you have 4 elements that are being applied. Your forward servo, which is applied in all 4 gears. Your second clutch, which is applied in third as well as fourth. And your third clutch, which is applied in third gear as well as fourth gear. The difference between third and fourth is that your fourth clutch is going to be applied. Your A solenoid is on, which is blocking fluid. Your B solenoid is off, which is exhausting fluid. Your fourth clutch feed will come from your 3-4 shift valve and come down through your number 10 check ball into your 3-4 accumulator, driving the piston in the opposite direction of fluid pressure, which will dampen the apply of your fourth clutch up here. So your 3-4 accumulator is associated with your fourth clutch up here, and the whole path to get there. Your 2-3 and your 1-2 accumulator are being used as well. So all 3 accumulators in this case are being applied. Your vent for your 3-4 accumulator will be located in your 3-4 accumulator valve. Your vent for your 2-3 accumulator is going to be located in your 2-3 accumulator valve, and your vent for your 1-2 accumulator is going to be located in your secondary 1-2 accumulator valve. Your secondary 1-2 accumulator valve is put in the position it needs to be in because of the fluid pressure that comes through your primary 1-2 accumulator utilizing your D4 fluid pressure. This part of the circuit, this small little part of the circuit right here, is called your primary trim. Your primary trim circuit is what keeps this valve in the right position for venting of your 1-2 accumulator. For fourth gear, your converter clutch solenoid is going to be on, which will enable lockup. The fluid the hydraulic fluid that passes through the converter clutch solenoid will be part of your second clutch apply fluid. So it's this same fluid that's going to be applying your second clutch is going to be flowing to your converter clutch solenoid in the on position, enabling lockup. All these brown spots here, these modulated sections, come from your vacuum modulator, which is not shown in the picture. However, the line pressure will be regulated by your vacuum modulator and be sent to all your accumulator valves to put them in the correct position for exhausting and flowing your third gear apply fluid and your D4 apply fluid. So with that all being said, that's how your fourth gear is obtained in the 4T60E.
The 4T60E GM transmission has many inputs as well as outputs that help electronically control this transmission. This is a vacuum sensor, and this is a throttle position sensor. These two sensors help to determine the amount of load that is being permitted onto the engine and can help determine which shift pattern the transmission will be making. This is an output of the engine speed sensor, and this is an output of the transmission speed sensor. These two right here are both thermostatic devices that are used to judge the temperature of fluid. This guy right here is the park neutral safety switch, and this is where the transmission gets its electronic output to determine what selection the driver's in the Prendl switch: park, neutral, reverse, drive, low, and so forth. And these guys over here I will be talking about in just a second. And these are the solenoids, and this is just where the actual valve body is located on the transmission. Right here is the B solenoid, and this is the A solenoid. Now, these are solenoids that are controlled. The PCM controls the ground, and when it controls the ground, it energizes the solenoid, and it is energized to block. This right here is the pulse width modulated solenoid, and as you can see from here on this diagram, as fluid comes in, it goes through here, and then it comes out and goes towards the torque converter clutch solenoid that I'll explain in just a moment. And now the thing with this solenoid is normally off except in 4th gear. And the special job that this solenoid has is that when it is in 4th gear, it meters the main line pressure so that it can send a correct amount of fluid pressure to the torque converter clutch solenoid, so that the torque converter clutch solenoid can provide the accurate amount of fluid pressure when in torque lockup. But when it's off, it exhausts the fluid pressure out through this little hole right here, actually. So, and now going back to the torque converter clutch solenoid and the A and B solenoid, because all three of them are exactly the same. They're just when they're energized, when they're provided a ground, they block. That's all they do, and they're very, very, very simple. And right here has the same kind of setup where when it's off, it just allows the fluid to bypass and just exit. In the reverse gear, solenoid A is on and solenoid B is on. When solenoid A is on, it is allowing fluid to flow to the 3/4 shift valve. When solenoid B is on, it is allowing fluid flow to the 4/3 shift valve and the 3/2 shift valve. And this directs fluid to the input clutch assembly. In 1st gear, the PCM provides a ground to solenoid A. When this happens, the mainline pressure pushes against the 1/2 shift valve. When the PCM provides solenoid B with a ground, mainline pressure pushes against the 4/3 shift valve and the 3/2 shift valve. So in 2nd gear, solenoid A is off. Because of this, spring pressure in the 1/2 shift valve is pushing up. The main line pressure is able to exhaust through solenoid A. However, solenoid B is on and is allowing mainline pressure to run and push against the spring pressure in the 4/3 shift valve and the 3/2 shift valve. And over here, as we can see, the pulse width modulated solenoid is currently off and allowing normal mainline pressure to bypass through it. As well, and the torque converter clutch solenoid is also off because there is no torque converter lockup in 2nd gear. So in 3rd gear, solenoid A and solenoid B are both off. And like in other gears, when solenoid A is off, due to spring pressure, it pushes the 1/2 shift valve towards solenoid A. The mainline pressure is being exhausted through solenoid A. And going over to solenoid B, same thing is happening where the 4/3 shift valve and the 3/2 shift valve, because of spring pressure, is being pushed into the seated position.
And because the solenoid A and solenoid B are off, as well as the pulse width modulated solenoid and the torque converter clutch solenoid are all off, this is the only gear that the transmission is not using any electrical components to operate. With this being said, this is what is known as the limp-in gear, and what that means is that if per se the vehicle lost all electrical connections to the transmission will still, or the vehicle will still be able to operate in third gear due to the hydraulic workings of the transmission. But the driver is still able to select a second gear option through the manual shift valve. And going over again, the pulse width modulated solenoid valve is in the off position, so it is allowing mainline pressure to bypass through it to the converter clutch valve, and the converter clutch solenoid is also off, so the mainline fluid is being exhausted through the converter clutch solenoid. In fourth gear, the solenoid A is on and allowing the fluid flow to the 3-4 shift valve. Now, the 4-3 shift valve and the 3-2 shift valve are exhausting mainline pressure through to the B solenoid, which is off. Now, mainline pressure is coming through this line right here into the 3-2 shift valve, which is forcing the return spring and allowing mainline pressure to come up this line and push against this spring on the 1-2 shift valve, which is preventing a 1-2 shift. And over here is the pulse width modulated solenoid that is currently on and allowing and modulating the mainline pressure to the torque converter clutch solenoid, which is also on. And when this is happening, it is varying line pressure in torque lockup, or torque converter lockup. And the torque converter lockup is receiving its mainline pressure from the second clutch assembly housing.
So if you want to know how this thing works, you gotta figure it out yourself.